All right, we're live. Welcome everybody to the Technological Podcast. My name is Sarin and I'm your co-host. I'm joined here by my two other cold co-hosts, both wearing jackets, Avi and Nish here. And we've got a special guest today on the pod, Natasha Vasadani. She's been making waves in the data science and computer science space, and she's been a long-time friend for many years. So I'll pass off to you, Natasha, and you want to go ahead and just introduce yourself to our listeners?
Yeah. Hey, everyone. I'm Natasha Vasadani. I live in New York. I am a senior data scientist for a tech cybersecurity startup company, and I'm excited to be here.
Awesome. Glad to have you. So we'll go ahead and just dive in. We got a packed agenda for today, and we'll pretty much just start off with your career and kind of how you've gotten to where you are. So right now you work at White Ops as a data scientist, but we wanted to talk about like how you got there to begin with and where you started.
Yeah. So that's kind of an interesting story. You all know I majored in industrial and systems engineering, and right after college, I actually started with Accenture working in manufacturing engineering. So I was actually working at like a copper mine out in Salt Lake City. Then I was at a steel mill factory plant doing a lot of optimization and throughput and analyzing machine runtime. Very different. No programming or any of that. Nothing cyber related. Um, I had always had an interest in computer science, and I missed the programming aspect that I was doing in college. So I left Accenture and started at PwC in their forensics technology practice in Atlanta. I think I was like the fifth or sixth person to join the team. So I was really excited because I wanted sort of that startup feel, but the big company benefits. Um, and I was primarily doing a lot of like financial fraud investigations, which were really interesting. I was getting to do a lot of programming, and I got very lucky in that when I started with PwC, we just got hit with, we as in, I guess the US got hit with the financial firms and the healthcare firms got hit with massive cyber breaches, like massive cyber attacks. So we were brought in, and PwC was asked on one hand to figure out where were these actors gaining unauthorized access, but then not only where, but what was getting stolen, what was getting breached, and how could we quantify that? What kind of PII was that? So they needed to bring in data experts to come in and scrape these servers and figure out what was happening, what was getting stolen. So that's where I came in. With that, I started working a lot with these network architects and cybersecurity specialists and started to learn so much more about cyber, and I loved it. I was just so fascinated by all of it, and I noticed a huge gap, which was cybersecurity specialists are so great with domain knowledge, but when it comes to a big cyber breach, they had very limited experience in large data and analyzing trends with large data. And then there's the reverse. You have people like me who knew so much about data and so much about analytics, but knew nothing about cyber. So I could find trends, but I couldn't filter out the noise. I couldn't tell you what that actually meant. So that's where I started to get into this like data science slash cybersecurity domain knowledge. From there, I started working on, rather than doing cyber breaches, I started doing more proactive work. So my last project with PwC was for a huge company where we were intercepting communication between their servers in the data centers. And we're collecting network signals and using those network signals to clean and create features to train models so that you could use these machine learning models to read communication and predict what type of server that communication was coming from. And that's where I really started to get into the machine learning, very, buzzword data sciencey stuff. And I was like, I just want to work for a tech company. I want to work for a product. I didn't like the professional services quite as much. So I found White Ops built in New York City, I think, and started talking to the data scientists there, had great conversations, and then they hired me.
That's awesome and very interesting to hear about, like the whole career path and everything. So I'm really interested in learning more about, how did you really upskill yourself in data science, especially because it's such a complex and broad topic and there's so many different technologies that you can use within, data science itself. So I'd love to hear more about, like how did you really up ramp? Like, what are courses that you took? Did you kind of like use any books? I'd just love to learn more.
Yeah.
And maybe just to preface that, why don't you, if you could just give us the plain definition of what is data science and what are the different paths, you can take within data science and maybe the ones you focused on.
Yeah. Okay, so what is data science? It is it's a field in which we use scientific methods, algorithms, and statistics to gain insights from data. That's what data science is. There are different methods you can take. So depending on what method you go around, but also what industry, that's how you would approach data science. You can go from the very basic, which you have more of like the data analyst, business analyst side of things, where you are doing slightly more high level, not quite as, you can use different functions that are in Python to train your model, to build your features. Then you go a little bit more in depth and you're like, all right, well, I'm going to actually build a model from scratch. I'm going to start tuning it from scratch. I understand the underlying layer of it. And then you've got neural networks and more deep learning. And this is even more complex. And it's very, very research focused. So there's those three things, but then there's also industry. So you don't typically, as a data scientist in cybersecurity, I will probably not be leaving cybersecurity. One of my biggest things is to build the domain, because without that domain knowledge, I'm not, like I said earlier, I can't filter out the noise quite as quickly. So it's kind of a, they say in the consulting terms, you got your verticals and your horizontals. It's very much like that. I see of you laughing. Yeah. But what I did to build it, one, I got very lucky in timing and where I was is a huge factor. Two, research. Like you are always in school. I found it funny. People would always kind of laugh when I would be, on a Saturday night. I was like, I gotta read some books. I gotta learn and read some research papers and stuff. But you have to research. There are always new algorithms coming out, and you're not you can't memorize all the current existing algorithms that are there. So you need to be learning all the time, and see what other people do with their open source techniques as well. So I was doing a lot of learning, like a lot of reading, a lot of research, not just on statistics, but also on programming. So I bought a lot of software engineering textbooks, primarily for the interviews actually, but that's also really important. And the other thing that was really helpful was the access to real data that I had through my companies. So I don't know if I could have gotten to where I am without using that real data and playing around with that. So I think that was like another really helpful thing, just spending just hours in the data, querying it, playing around with it, doing different visualizations on it. That was like another big factor. It was a lot of time outside of my job.
Yeah, for sure. Yeah, totally. That's awesome to hear, and thanks for that explanation. It's very helpful. I'd love to dive a little deeper into, you mentioned the data science interview. What is the interview process like? How is it structured? We just start from there.
Yeah, so it's really different depending on what level of data science you want to get into. I'll use the one that I had for White Ops as an example. It was very software engineering focused. So there were questions about different statistics, just like how would you solve for this, and saying different statistical formulas. But then there was also a large component of programming. So just being able to program different objects, making sure you can do object-oriented, making sure you can do graph traversals, the typical software engineering stuff. And then on top of that, what are the different machine learning models you would use? Why would you use this one with this data set? What outputs? What is a bias? What is a variance? Those types of questions. It's really technical. It's very, very, it's not as focused on behavioral, I would say. I think I had 4 technical interviews and maybe 1 30-minute behavioral interview, or maybe 5 technical and 1 30-minute behavioral.
Awesome. Yeah, that makes a lot of sense. And just kind of to piggyback off of that question, since I'm sure there's consultants that are kind of doing data science work today, that may want to take that transition you took from a consulting firm and providing services to a client to actually jumping into a product centric company where you're doing data science for them. What would you say is kind of been maybe the life cycle of the data science work you were doing at PwC versus the kind of life cycle or the type of work now that you do on a day-to-day basis, the kind of the key differences, if there are any?
Yeah, I would say the biggest difference in professional services data science is the focus is on quantity over quality, whereas in tech, it's quality over quantity. In professional services, and it makes sense with how the company generates its revenue, right? We are selling our professional services. We're making money. We want to get you the answers as fast as possible. And in most cases, you can have a hiccup or two. You don't need to be quite as precise. When it comes to a product, the tech companies have a much better understanding of investing time and research, so you may not have returns immediately. So there's a lot more that goes into the quality of the product. You're deep diving, and you may not communicate with other people for a few days, until you find your insights. Whereas in consulting, you're trying to do things as fast as possible. Aggregate everything as fast as possible and make assumptions here and there. Like, all right, it's okay if we lost this data. Let's just ignore that for now and continue on with what we're doing. So that's been a huge difference. The other difference is that with consulting, you're moving from project to project. So you're dealing with different use cases every single time, which means you're almost starting from scratch in a very short period of time. Whereas on a product, you're not moving from use case to use case. You're on one use case and you're building on that, and you're watching data change over time as in like years over time. So those are probably the two big differences.
I think that makes a lot of sense. And I also came from professional services, so I definitely understand the quality over quantity aspect of it. But I'm really curious to hear just like a day-to-day, like what does a day-to-day look like for you at White Ops? Like I've heard that there's a big focus, like you go into data science, but a lot of it's kind of focused on data engineering. I would love to hear like, the split on that and like, what tools you use on a day-to-day basis as well.
Yeah. So on a day-to-day basis, data science, you're right. Data engineering is a huge aspect of it. You will probably spend most of your time cleaning data. That's like where all of my time goes, is just cleaning data. But as far as day-to-day go, what I've really been focused on lately are building visualizations and monitoring in place, using those visualizations to drive insight and then digging in. So we'll have these dashboards in place that we create, and we'll use tools like Python. We're big fans of Altair in Python, which allows for some interactive dashboarding, like interactive visualizations. There's also Plotly, which is great. So, and just Matplotlib in general. So we've got a lot of these dashboards, and we create sort of automated systems that'll run and generate these dashboards and alert us if there's something weird, which is in fraud happening all the time. When we get that alert, we'll look into it and then start building a lot of Jupyter notebooks to bring in more insights. At the same time, that's kind of the, I want to say like very operational side. Usually each data scientist has a big research project assigned to them, which they're focused on building from scratch. So the research project I'm working on right now, I am working a lot with data engineering and machine learning engineering, actually. And we're trying to do great, like, I don't know how much I can say. Actually, that's what I'm like, handling big data in real time, streaming events, and observing statistical anomalies as we are receiving the data before it gets into our database to aggregate and look historically. And so there's like another project, we're doing a project around more types of behavioral methods when humans are interacting with certain pages on the website. So those are like long-term research projects, and you'll study research papers, you'll buy articles, you'll have textbooks, you'll be reading through that, you'll build things, there's a lot of proof of concepts and writing papers. We call them like RFCs, requests for comments, that you'll be focusing on and putting in all of your research in there and your dashboards, and then having other engineers come and look at it and suggest things. And it's kind of like that iterative cycle.
Awesome. Yeah, appreciate that. That was awesome to hear. And I also heard like a few other things that Natasha was mentioning, like Jupyter Notebooks. You said there was Plotly that you use. So, there are a few different like apps and tools that data scientists use on a day-to-day basis, and we can link those in the description for you all to check out and familiarize yourself with. But I think we were gonna kind of divide this podcast into two sections: data science and cybersecurity. So, Anish, Avi, if you guys have any more questions about data science, feel free to ask. Otherwise, we can move over to cyber. What do you think?
Yeah, I think we're ready to move on to cyber unless Anish you have something. But I'm really interested to hear your take on the cyber industry, Natasha. I know it's such a massive industry, and there's been so many changes, and like especially with all the remote work.
Oh yeah.
There's so much. It's like fragmentation. So yeah, I'm really excited for this section.
Oh yeah, let's do it. I think we can talk about data science for forever, right? But let's get into the cybersecurity stuff.
Cool, awesome. So we'll start with just kind of like what you did with data science. What is cybersecurity?
Cybersecurity is the security or the protection of the internet or all things computer related. That's all I can say.
Yeah, that makes total sense. Very, very simple definition. Like what would you say is why is cybersecurity of utmost importance now to businesses, and where is cybersecurity heading in the future?
Yeah. Well, for one, we're moving everything, all of our sensitive information, everything we own to the internet. So protecting that is becoming bigger and bigger. And it's so easy to now steal things. You don't have to be physically active to go and steal things. You can do it from anybody can access you can make thousands or hundreds of thousands or millions of dollars from your home in New York by accessing a bank out in Europe. And that's crazy. You don't need any physical activity, no effort in that. And that's why cybersecurity is such a big deal right now.
Yeah, and as we create more and more technology, obviously the need for cyber grows more and more, right? Like more endpoints means more vulnerabilities. So I'm just really curious to hear, what do you think are some of the bigger challenges that are facing the industry? And like, I know maybe you can't be so specific, but like, what are you kind of seeing at White Ops? I know you guys focus a lot on like fraud protection and bot like identification. So I'm just like really curious to hear that aspect.
Yeah. So the biggest thing, which I'm sure you all will not be surprised about, is data privacy. Data is really important for fraud and cybersecurity. Without learning that data, without collecting that data, it's very challenging to find anomalies. However, the collection of that data can do a lot of damage to our society. So that's a huge challenge that I think we are having to deal with. In another sense, I guess, like the sophisticated fraud always disguises itself as orthogonal behavior, and you need data to be able to identify those anomalies. I see ourselves shifting with cybersecurity and with data science in a way that we begin doing these methods with a more privacy-driven approach rather than what we're doing right now. And I think a lot of companies are doing that. A lot of companies are getting rid of the cookie. A lot of companies are trying to get rid of user agents even, getting rid of passwords, becoming more, bio-focused, right? So I think that's going to be a big challenge as we go forward. And that, but also at the same time, maintaining customer ease of use for a company. Like you don't want to, if you think of a bot mitigation company, a bot mitigation company wants to collect data and verify that you're a human. But if you're a human and you're logging into your bank, you don't want to have to wait for a PIN to your phone, right? It's like, let's say you're in a different country, you don't have cell service, you can't log into your bank because you're connected to a weird Wi-Fi, and they can't approve you because you've lost your phone, or because your phone doesn't have service, or even because you've lost your phone. Then you're stuck, and then you're annoyed, right? So how can we stay privacy driven, but also make it easier for humans to get access to their personal information?
Kind of to go along with that, in the in the light of data privacy being such a forefront concern for consumers and for businesses, how do you think that impacts kind of the role, you play as a data scientist when a lot of your job is to derive insights based on PI, based on PII, based on, your customer data, right? How do you think that kind of, that narrative plays into the data you guys can derive?
Yeah, so I think what the data scientist role in this, as we move towards a privacy-focused, I guess, cybersecurity, would be to learn how to collect data such that we are not collecting your personal information, or train models locally rather than having to collect all of the data gathered and place it on a single server, which is what people are doing right now. It's called federated learning. So the idea is that you can, I think one of the idea is that you can train models, or at least an aspect of it, on a user's local server, and then you can send that trained or aggregated statistics over to the global server, which can then incorporate it into its overall model, and then take it out and send it out to the other servers to learn from that. So there are a lot of things in place that are happening right now to build better models that are not super privacy violating, I think you could say. And it's up to a data scientist's job to help work with the cybersecurity specialist to understand. So what I think that's the other thing, is understanding what is a privacy concern. There's things like, okay, IP address, you can track that IP. You can use an IP to identify a user, so that's PII. But then there's also something like, all right, well, what if I'm grabbing your accept language from your headers, right? That's your language. Can that lead to a bias based on your language? I can then maybe infer what your ethnicity is, or what language, what country you're from. Then that could be a bias, and that could be a privacy concern.
Yeah, diving a little bit more. Yeah, very, very interesting. Yeah, diving a little bit more into like bias is like how are you creating models that can help detect this kind of bias? Like, are you what goes into that?
So we're creating models to not have as much of a bias, is what we want to do. And this was another thing I think that we're moving towards with both cybersecurity and data science, is building ethical models as well. You don't want your model to have a bias. A bias example would be, there was a study on using machine learning to parse resumes and determine which resume is most likely to get the job at a company. What they do is they use the supervised learning approach, where they feed in the resumes that they've collected over the years and which resumes actually made it across the different rounds. That machine learning model immediately developed a bias in males. Most of the people that they had been hiring were males. Now this machine learning model, even though you didn't specify, you didn't really say that it should be male, it's biased towards males. And that's essentially a flaw in your model. So you want to make sure that what features you put in don't allow for a bias to come.
Got it. Yeah, that makes sense. Okay.
There was, I guess, kind of going along with that, what I was talking about, the ethical part, there was another study where they're talking about like ethical machine learning, where one example is you have these automated or self-driving cars, and let's say the self-driving car is about to be in an accident. The machine needs to be able to, and there's a child on this side and an adult on this side. The machine has two choices, right? It could swerve to this side and kill the adult, or it could swerve to that side and kill the child. Should it be biased and swerve to the adult because there's a child there? So there's a lot of really interesting stuff on like the ethical side of data science as well.
That's crazy. Yeah, wow, that's awesome.
Yeah, that is super interesting. I mean, you're really only as good as which data you have, right? And like, I think just more biased examples, you had the Apple Card problem where they were giving certain people lower credit scores. So yeah, it's a really interesting topic. But I kind of wanted to take us back to data science just for a little bit, because I think there's actually one thing that we forgot to hit on. And it's kind of around what does a career look like in data science? And I know you mentioned right at the beginning that once you join the cyber community or like the cyber industry and like you're a data scientist in the cyber industry, that's kind of where you're going to build yourself. But I'm really curious to hear like what does a career in data science look like, and what can you expect like the next level? What does it look like? What you will be doing, and how do you really see that evolving?
Yeah. So there's two routes you can go. There's the IC route, and then there's the management route. The IC route would typically be well, before you even get to management, the main route for most data scientists, it does typically require a higher degree above bachelor's, so a master's or PhD in some sort of engineering. Surprisingly, a large portion of my team have PhDs in, I think, physics and chemical engineering. So after that, or if you have, I think, sufficient experience as in the corporate world, so like several years out of undergrad, but after that you become a data scientist. Then you go into a senior data scientist. From there you go into principal data scientist, and then I think there is scholar, distinguished, and then chief scientist. And that whole route is the IC route. You are doing a lot of research. You are not dealing as much with corporate. You're not dealing as much with executive team. You typically have, in those cases, you typically have one major research project that you're focused on, and maybe a few people that report up to you. Then there's the management route, and you can, so after senior, I believe you can transition at any point, but you can then become a data science manager, and from there, a senior manager, a director of data science. I think you can even get to chief scientist. I don't know, that's way above me right now. My dream would be a chief scientist. And our current chief scientist did go up the management route, and I think we had another chief scientist that went up the IC route. So I'm under the impression that you could go both ways and then end up at chief. But that would typically be the way. So it really depends on, do you want to stick solely to yourself and do a lot of research, a lot of more academic focused research, or do you want to start doing research, use your research to then build a team and communicate that across with your other departments, your engineering and your sales department, and move up that way.
Awesome. And if you had to pick maybe two skills that you would say are the most crucial to succeeding, just maybe generally as a data scientist, and then maybe there's overlap within the cybersecurity space as well, but maybe two skills in the cybersecurity space to succeed, what would those be?
Two skills. The first one, I would say some sort of engineering. I think that's really important. The ability to understand formulas and apply them and derive them theoretically is really important. And I think that's something you get from engineering. I'm sure there's another background that might help you get that too. But some sort of, that's the first thing I can think of. And a lot of that goes from most of the greatest data scientists I've seen have an engineering background, although I'm sure that's not necessarily true. The second skill I would say, I don't know, I honestly, okay, this is what I would say. The ability to translate these complex insights into something that your executive board can understand. Because if you can't do that, nobody will take action on what you found. And I think that's a huge challenge that a lot of data scientists face right now.
Awesome.
Yeah, communication is definitely key, in taking data and being able to put it in whatever medium and then being able to translate that properly. So I'm really curious to hear, like, let's say you really want to get into data science right now. Like I'm a student in undergrad, and I know I want to have a career in data science, but I really don't have a background in it. And maybe I'm a computer science major, maybe I'm an IE major. Like, what are some things I can really start doing right now and taking actionable steps to achieve my goal?
I do want to go back to say, when I was at engineering, I think I was thinking more like just math. You need background. It's heavy math. So you need background in math and be really good at it. For somebody right now that's a student in undergrad that wants to go into the data science route, I would say and I say this, and I don't even have a higher degree, but I would say look into a master's or a PhD as a next approach, because I personally know that it can be very difficult to even have somebody look at your resume without that. I don't like that. It would be easier. The other thing I would say is, which is almost kind of contradictory to that, but so much of what you learn may be on the job. So really study all of your theoretical concepts pretty well, but in the end, you're going to need to see real world data before you can, or play around with real world data before you can really get to that data science. Before you can get to that data science position. That's a tough one, because I honestly didn't even know what data science was when I was graduating college.
It's changing so much now. Like people in college are starting to know about product management, data science, like everything's so fast. It's unbelievable.
I didn't know what product management was. I didn't know what data science was. I was set on being a manufacturing engineer or a spy. Those were the two things. Cool. But I guess one more thing I wanted to add though is even if you're not a computer science major, you can still be a really good data scientist. That's something that I've seen. I've seen people with biomedical engineering. Like I said, my whole team is primarily physics PhDs and chemical engineering, two things you wouldn't typically expect to see as data scientists.
Yeah, I think that's really powerful, and that's almost like a common thread that we're starting to learn. Like, you don't really like going down a specific major doesn't necessarily mean that that's going to be what you're going to do for the rest of your life, right? Like, if you want to get into data science or whatever it is, like it's you learn these different applications, you get a master's, you read online, you take like online courses. There are a bunch of different ways to learn about those.
Yeah, so much is available online too, and I think that's great. I think that's changed drastically in the last several years too. A lot of the courses are becoming even free online too. Something that I do is I kind of take some of the same courses over and over again, because you tend to forget and they can be very complex. So I've taken some of those Coursera courses probably like 4 times.
Dang.
And learn something new every time.
Wow, that's awesome. Dang. Cool. Well, I have one more question for you. I think we're getting close to time. So I was gonna ask, so you're building these models that pretty much detect like bot fraud or other kinds of fraud. Like, what is something that, I guess, what's the biggest thing that you've learned while doing this?
Biggest things I've learned. One is to keep things simple. Don't overcomplicate. Sometimes a simple group by can show you extremely interesting insights rather than going through and building a full model. That's one thing I've learned. The second I've learned is visualizations are some of the most important, interactive visualizations. The ability to build that on your own and play around with that, you can gain so much more than what you could with writing or trying to, build a machine learning model as well. And the other thing is that real world data is so much harder to find trends in than the data I'm used to working with in school. You'll find something and you'll be like, this looks suspicious, and then you'll see it happen way too much all of a sudden, and you're confused, and you find out that Thailand devices operate differently than US devices. So it's anomaly, but it's anomalous, but it's actually not anomalous if you're looking at just Thailand. So it's something, it's challenging, and it's been really interesting just to learn how different data can be across the world.
Sweet.
Cool. I've got, I'll take my last question here as well. And in your organization, to the extent you can discuss, how much would you say you guys build your roadmap or your features and future looking things based off of the data you guys are generating around how your customers are accessing your different products, and the insights that you as your data science team are generating from those.
Like how often we're focusing on just building out features or finding what the feature should be, essentially.
Well, how much weight do you guys look into the data around how your customers are using your different products, and then taking that and building out insights from that, communicating that to your leadership team, and then saying, oh, we should look into this space, or we should maybe try something here because this makes sense, right?
Yeah, for me personally, because I work in our application security, and each customer is a different application with different use cases, we're actually doing that a lot. What the customer can provide us, we consider ground truth, and we use that to help tune our logic and also figure out where is the demand, where are the trends happening, what should we focus on next. For example, we're learning that mobile in-app is becoming huge, and we're learning that through conversations with our customers. We're also learning for financial institutions, credential stuffing account takeover is no longer as big as new account creation. So let's shift focus. Let's start looking at threat models that can do that are focused on new account creation rather than focusing so heavily on credential stuffing. So it's a huge driving factor for what we research next.
Awesome. Yeah, I know, because I'm a product manager, and I know when we do specific business reviews, we look at feature consumption, right? And our data science team does a good job of getting really into the weeds and understanding, are customers really using this feature? Are customers not? And what's the growth rate, right? And so sometimes we'll see, a feature not being used, right? And then we can go and investigate whether or not it's worth continuing to market that or reposition it, right? And those kinds of insights coming out of data.
Oh yeah, no, that's interesting. I actually don't do anything similar to that, because our product is our bot mitigation tool that's essentially self-serviced. So our product is essentially our machine learning models and our detection logic that's telling the customer whether it's a bot or not. But that's interesting, because I've never really done data science with a product to do, sort of like a kind of like an A/B testing is almost what you're saying, like what features on a product does a customer use. That's definitely an interesting one, and I'm sure they probably use very similar analytics that I do, but almost like in a completely different sense.
Different use case, yeah, more for internal data, insights and analysis.
Yeah,
cool.
I think that's actually pretty important to call out for our listeners. Is like there's data science, like you can be a data scientist and build these models that will help, like you said, detect fraud for companies. Or you can be like almost an internal data scientist where you're helping glean all these kinds of insights that will inform product roadmaps, or you're a data scientist for maybe like a marketing department, and you're able to figure out like, okay, like how's our content performing over time? What are the reasons why this content is performing well? So yeah, there's definitely a bunch of distinctions around that.
One thing that would be a little similar, what we are doing right now is trying to detect adaptation. So when we consider a session as a bot, the customer may choose to block that bot or deceive, which we prefer for deception, because when you deceive a bot, it takes them a lot longer to realize that they're getting blocked. But for customers that would just straight up block, if we say bot, the bad actor or the actor behind that bot will see that they're getting blocked and immediately try to change something, and then try to change something again. So you'll see what's really cool is when you're visualizing this data and you put in all your features in a cool graph, you can see bots adapting and starting to test different things, seeing that it work, and then like shoot up and start attacking like crazy, and then get blocked again, and then do something like that again. So it's really cool, and I think that's probably similar to like feature testing. We're seeing adaptation, and then my team has to go in and figure out, all right, they're adapting. How do we keep modifying our logic or our detection to stop them?
That's awesome. Yeah. I think cyber is a very interesting space to do data science.
Yeah, it's pretty fascinating. I mean, like data science, cyber, like the whole array is like so fascinating because there's so many different like segments that you can go into. I think we could probably talk for like more hours on like how does data science differ across different organizations, like, and even like how does cyber differ across different verticals. So, but I actually ended up asking my last question a couple questions ago. So this was super helpful, Natasha. Thanks so much for taking time out.
Yeah, definitely. Glad I could help. And I know I could talk more about cybersecurity. It's still, I'm still trying to gain or get better with the domain knowledge for cybersecurity as well. I'm definitely at a much stronger point than I was a few years ago, but I sometimes you will be talking to, I'll see something that I don't know if it's interesting or not, and I'll talk to one of our security researchers, and they'll say, "Oh yeah, that's what this is what they're doing," and I'm like, "Whoa, okay, I wish I knew that." Like I wish I knew that a month ago, and I would have changed the way I was doing some of this.
Yeah, actually, well, maybe I do have one more question.
Yeah.
But it's like, so we talked about like breaking into data science, right? But cyber is a pretty niche industry, right? Like you don't hear about it a lot, especially coming out of undergrad. It's not like a quote unquote like you go to Facebook or you go to Google and you work on like products and like what advice would you give to someone who wants to like break into cyber? Like I know these big consulting firms have really big cyber divisions, like Accenture has like Accenture Security and like PwC. But like, what advice would you give someone who like just wants to be in the cyber industry in any capacity?
I would say there's a lot of courses that you can take for network architecture and cybersecurity, TLS fingerprinting, understanding all of that, the network layer. That's really important. And then there's the other aspect of not just like the network layer, but also what are the different threat models that we see in cybersecurity. So you've got different types. You've got phishing. You've got credential stuffing, you've got brute force attacks, you've got manipulated requests, you've got man in the middle, you have even one crazy one I dealt with at PwC, social engineering. That's another weird, very difficult to detect, but you can get social engineering into cyber, right? Convince somebody to give you their password or learn enough about them that you can log into or you can impersonate them. So there's a lot of different, it's still growing, and I would say a lot of online courses, and definitely go. I think a lot of the cybersecurity jobs that are looking for lower positions or people just out of college are not expecting you to have so much of a domain knowledge, but that willingness to learn. So I think that would be my advice: is do a lot of research.
Yeah, definitely. We may have you come back on and break down all the different types of attacks.
Yeah, seriously. We can do like 3 episodes on that alone.
Yeah.
Yeah. I will say the best thing about working in both the financial fraud and cybersecurity is your day-to-day work, like mitigating an attack and then or finding something and then watching on the news like people go down because of your finding is really interesting. It's crazy to see how the work that you do actually has an impact in the real world.
Awesome. Well, that was a great way to end it out. Go ahead, Nick.
I was just going to say, I know you've mentioned a lot of courses, so we might need some names of these courses so we can link them for our audience.
Yeah, definitely. I can send you some of the courses that I've taken. I'll see if I have any of like the papers I have, but I have a lot of textbooks as well. If for anyone that wants to read.
Awesome.
Sweet. All right. Thanks, Natasha. It was a pleasure having you on, and I hope everybody learned something from this. This is really helpful. And again, we'll link all these great resources that Natasha has in the description. And if you have any feedback, of course, let us know. Our email is in the description as well. Send us an email. Hit us up on Twitter. Like and subscribe this channel. And thanks again for tuning into the Technological Podcast. Have a great weekend, everybody. Bye.
Thanks, guys.